Assalamu alaikum everyone. Hi my students. I'm Muhammad Salem, the lecturer of the Practical Organic Chemistry at Chemistry Department. So you are very welcome at the first lecture in this academic year 2021. As you know, due to the COVID-19, we have to meet via online, not face-to-face in the lab. I hope to see you as soon as possible at my lab. So I make this video to show you and to talk about some important things, some general information in organic chemistry, and of course to refresh your memory about some principle that we can use and we can get benefit from it in this experiment lab. So let's go with this PowerPoint. As you know, in organic chemistry we study the structure, the properties of organic compounds, of course with their reactions, preparation of them, and in general they are divided to two types. Type number one, produced by living organisms. Type number two, human-made substance, the substance which made by a human, such as plastic or drugs or any human-made substance. Both of these types of organic compounds have a range of application, wide range of application in our life. So in the following slides I will discuss with you some benefits, some advantage and disadvantage of using those organic compounds. First of all, we have here the sucrose, the ordinary sugar we usually use every day with the tea. The second one, isooctane, which is the major consists of butyrol. The third one, vitamin C or the ascorbic acid. All of them have enormous uses in every day of our life, but some of organic compounds, they have disadvantage or harmful use when they use by wrong hands. So the structure of cocaine, and look at this situation before using cocaine and after using cocaine. Another structure of organic compound we call cis-9,10 octadecanoate, which is a sleep-inducing fatty acid derivative. So this organic compounds induce the sleep. The other organic compound which called cis-9-trans-11 conjugated linoleic acid, which is derivatives of fatty acid. So this is we can use as anti-cancer agent. So look the bad side of the wrong uses, look at the good side of the good uses as drug and beneficial uses. Another examples of organic compounds we called Zantac, commercial name, or ranitidine. Of course, this structure of ranitidine and the most common antibiotic material, or we called amoxicillin as a commercial, but it's belong to the beta-lactam family. We use it for treatment of bacterial infection. Another uses for organic chemistry, the structure of tenormin. This is from the family of beta blocker, which is cardioselective. We can use this to prevention of heart disease. And the other organic compound, the general name or the commercial name captopril, used as the prevention of hypertension. زيادة الضغط. Another organic compounds like fluoridine, we use it as antiviral compound, antiviral which means مضاد فيروسي. The other one we called هالامون we can use as the anti-tumor مضاد للجروح أو معقم للجروح أو معالج للجروح. Some of the organic compounds, the natural or the modified or the prepared at the lab, we can use as a pythrine, like natural pythrine and human-made pythrine. These are a structure of them. Organic compounds, they are found in everywhere in our life, like Refresh perfume. The Refresh perfume integrates consists of all these organic compounds. You can see palmitic acid, triethylamine, glycyrrhetine, isobutane, and etc. Not only in the perfume, we can see organic compound in the dyes and the paints. So this is indigo, the responsible color of blue jeans. Of course, the original one, not the Chinese one. Another organic compounds responsible for other colors like Gick's pigment rate and colorless. We can see here another organic compound responsible for different color like green, red, and magenta pigment, which produce in the factory from two colorless organic compound. Another organic compound which is responsible for jasmine perfume, we call cis-jasmone, which is a ketone. The responsible for smell of roses we call damascenes, which is also organic compound from the alpha beta unsaturated family. Those two organic compounds responsible for food dyes. غذائية. Look at this structure of alkyl pyrazine, which is responsible of the smell of coffee. The floronol, which is responsible of the roast meat taste. The chloranil or the caramel, we called caramel. We can taste this taste from the chocolate or another sweets. Maltol, or commercial called E636, we call this organic compound as E636. You can read this sample at the biscuit and cakes. Of course, all of us, we know the vanillin, which is found in vanilla pods, the structure of vanillin, and the menthol, which is extracted from mints. This is menthol, which is responsible of the mint taste. Now, the other human-made organic compound we called aspartame or NutraSweet, which is 200 sweeter than sugar, the ascorbic acids, and methyl ester phenylene. This part from aspartic acid and this part from methyl ester of phenylene. We can condense them and prepare NutraSweet, which is sweeter than sugar 200 times. This is additive for the, sometimes in the market you can see we call diet coke, diet soup. So this these types of diet don't have or don't contain any sucrose but contain a neutral sweet which is sweeter than sucrose. From all those organic compounds that we are used every day, usually every day, so we have to understand organic chemistry, we have to understand the organic compounds, what occur, how chemical reaction take place, how preparation of these organic compounds. So at this semester we will show some reaction, some preparation of organic compounds, and describe it and discuss their mechanism. You know, there are many types of organic reaction. First of all, addition reaction. The second one, elimination reaction. The third one, substitution, and the rearrangement reaction. If someone asks you the reaction between this starting material with HCl will produce 2-chloropropane, so which type of reaction this reaction belongs to? Is it elimination, rearrangement, substitution, or an addition reaction? Of course, there is no losing any atoms or groups from the starting material, so this reaction is not elimination. Is it rearrangement? Of course not, because there is no group or atom replace this place or position from this carbon to another or from this position to another, so there is no rearrangement reaction. Is it substitution reaction? There is no atom or a group replaced in place of the another atoms, so is not substitution. The good answer or the answer of this reaction, of course, is it is an addition reaction. Addition reaction because we added one hydrogen at this position and the chlorine at this position, so this is addition, not replacement, not substitution, not replacement, movement from position to another position, so this not rearrangement, not losing any atoms, so it is not elimination. So to describe all those type of organic compounds or organic reaction described by mechanism. What mean by mechanism? Mechanisms mean the steps of organic reaction that describe step by step these organic reaction to understand the starting material, the intermediate, the final product, which atom attack which the division center, which is the rich center. So this is the mechanism. Mechanism will focus and will discuss many times on in the mechanism of the organic compound in this semester. So in general, mechanism of organic compounds divided to symmetrical and unsymmetrical. In general, mechanism of organic reaction divided to symmetrical and unsymmetrical. As you know, symmetrical we call a free radical reaction, and the polar mechanism or unsymmetrical reaction we call nucleophilic, electrophilic, or rearrangement. Same mechanism called in bond breaking and in bond making. Symmetrical and unsymmetrical. Symmetrical for the radical, unsymmetrical for the polar, which is divided to many types: electrophilic, nucleophilic, rearrangement, etc. So so in this slide here, a very important thing, the way of drawing. Look at this slide. And this slide very important. This slide shows very important thing, which is the way of the drawing the curved arrows. Look at this head and look at this head. This we called fish hook, or the half head arrow, which is usually or must we have used the with radical process or radical reaction. And another one with the complete head indicate to polar process, nucleophilic or electrophilic substitution or addition and general reaction. So this two arrow very important. I'm always look forward during the examination. This is an example of the half head arrow, which is used as in the radical reaction. It's very important the mechanism of the reaction in this stage, so be sure that you drawing with correct way. Another term, I hope you focus on it. We will use in the, or we will get benefit from it in the first experiment and the second experiment maybe, which the term called electronegativity. Electronegativity, which means the tendency of an atom to attract shared paired or share electrons from electron toward itself, like oxygen, fluor, nitrogen, chlor. Look at the chlor in this atom with high electronegativity. So there is difference between carbon and the chlor. So the electron negativity of a chlor high, chlorine will attract the electrons from carbon and hydrogens to itself. So this area will be high center, high saturated with electrons from another atoms. So there will be high electronegativity, partially negative, which means high electronegativity, partially positive, which means low electronegativity. Look at the blue color, which is division center, Markaz Faqir, rich center of electrons. Opposite of this organic compound, methyl lithium. Methyl lithium, very low electronegativity. The carbon is higher than lithium in electronegativity. Look at the electron cloud around the lithium, which is colored by blue, being division center of electron. Opposite to carbon, which is partially negative of electron, which rich of electrons. So these color very important to understand the electron distribution around the atom and the groups. Same thing with all of those functional groups, alcohol, alkene, halide alkyl, amine. So all of these functional group have an atom with high electronegativity. So the electronic distribution at around or surrounding atom or group will be different, from negative position to positive positions. So this difference in electron distribution will lead to another subject or another material we called a polar reaction due to the polarization, which means a change in electron distribution as a response to change in electron nature of the surroundings, electron surrounding of atoms and a group, which lead to polarizability, which is tendency to undergo polarization. Polarization is responsible for polar reactions, polar reaction between high electron density and low electron density, division center and rich center، مركز غني بالإلكترونات، مركز فقير بالإلكترونات. So this is polarity. For example, the molecule of methanol, look at the oxygen, which is high electronegativity surrounding by high polar negative charge. When you added some acids to the methanol, so this oxygen will be protonated by another hydrogen from acid, and look at the difference distribution surrounding the atoms. In this case, a methanol will look the red color concentrated on the oxygen, which is a rich center of electrons, and the protonated methanol, look at this color, the difference, the little difference between electron distribution surrounding by atom or group. So look at the blue color, strongly electron poor carbon, strongly of course electron poor carbon, but in this case strongly electron poor carbon, because the oxygen protonated by another proton, so there is somewhat similar distribution of electrons without difference like the usual methanol. Of course, same thing with the sulfur, with the iode, with the chlor. This subject leads us to talk about two terms. We use it also in this course: electrophile and nucleophile. Any electrophile, it is electron poor spaces. Any nucleophile, which is electron rich spaces. Always the nucleophile attack electrophile, not opposite. Electron rich center, electron rich center. The nucleophile, the electrophile, it is a electron poor or without electrons. So always a nucleophile attack the electrophile. And look to the head of a row, not half a row, complete head a row, which means the polar reaction, nucleophilic, electrophilic polar reaction with complete transfer from two electrons to electrophiles. So the electrons that move from B to A end up here on the A. So we used complete head arrow. Another structures for high electronegativity atoms, look at the chlorine negative, the hydroxyl negative. Focus on this molecule. We will use in many practical experiments. So this is a real OH, full red color, which is mean high electronegativity, rich center, can abstract the hydrogen easily by this atom. Look at the amphoteric compound H2O at the side of oxygen has red color, which is mean high electron negativity, high electron. The other side blue color, which means division center or poor electron, or the cloudy, the density of electron is low. Another one, most important group in organic chemistry synthesis or preparation in organic chemistry, we called carbonyl group, partially positive, partially negative, which mean red color on the oxygen, blue color in this position. Why? Because high electronegativity of oxygen. Oxygen will attract the electrons from all these positions on it, and the cloud of electron will be low, the density of electron will be low. So any high electronegativity, any negative charge can easily attack this position, which is colored by blue, division center. Another example for methyl bromide and Ag3 oxygen. Look at the difference between Ag3 positive and the H2O. So there is no more electrons, no more red color. This reaction will show the addition of polar reaction between ethylene and hydrogen of bromide. Look at the red color. Red color from the extra double bond or pi bond, we call pi bond. So this is red color. The blue color of the proton, hydrogen, which is division center, poor center of electron. Bromine is higher electronegativity than hydrogen and carbon. The product we called bromethane. Mechanism of this reaction: the negative charge, the rich center of electron, will abstract this blue color position, blue color hydrogen, and leave the Br with high concentrated of density of electron, high negative charge, which is in the second step will attack the position positive carbocation or carbonium ion. This will be full blue color, which is division center of electron. Rich center attack division center to make new bond between carbon and brom. So this is the addition of reaction between HBr and ethylene. Using curved arrow in polar reaction. Don't forget this. I always look after using the arrow at the mechanism, the atoms, the groups, which groups attack which atoms attack which. So be careful when you answer in your exam. Curved arrow are way to keep a track of change in bonding in polar reaction. That's the importance of the using correct arrow. The arrow tracks electron movement. The arrows means the electron movement. One electron, which means half head, double electrons, or a pair electron, which mean full complete half, full complete head arrow. Electrons always move in pair with in polar reaction. Don't forget nucleophile. The electrons go from the nucleophile to the electrophile. Rich center attached to division center. Rich center attached poor center. extra electrons always attacked zero electrons or less electrons, so the nucleophilic site can be neutral or negative, but the electrophile always be positive, which is zinc or Bohr center or division center. And look to the shape of the arrow, head, full head arrow, not half, and always from this position, from negative charge to the positive charge, not opposite. Some of example to using curved arrow, negative abstract hydrogen to leave bromine with negative charge. Another examples, negative charge will abstract the blue hydrogen or the division center and make neutral H2O. In this case we will produce positive charge, which is carbocation. To complete in another step. I think that's all for today. Just I wanna explain the syllabus of this semester of this course. We will start with aldol condensation, Cannizzaro reaction, Perkin condensation, pinacol arrangement, and maybe we'll take diazonium salt in this course. If not, will be in the second semester inshallah. Diazonium salt, of course, sulfonation of aniline to produce sulfonilic acid. The other experiment maybe we will take Diels-Alder reaction, oxidation of side chain, isolation of caffeine from black tea, and oxidation of aromatic multi-ring, preparation of anethraquinone. If there is a time, we will complete with another experiment. So all these experiments are chosen carefully. I mean, some of them we will see related to the theoretical organic chemistry with the Dr. Rashini, like aldol condensation or Cannizzaro. Some of them are pinacol. Some of them have been chosen to learn from it some technique at procedure, at experiment. So like stirring technique, like reflex technique, like workup, like filtration, gravity or by Buchner, etc. So we will learn from all these experiments some of organic principles that related to the theoretical organic chemistry, and some of them we will learn from them some techniques which usually used to preparation or in the reaction of organic compounds. So next week I will discuss with you about aldol condensation. I will attach the experiment theory at the model site. So then we'll explain together the procedure and the mechanism and the aldol condensation. Until then, bye bye, see you soon.